We've talked about how to add vectors, but now we're going to talk about two different ways to multiply vectors. The first one is called the dot product, or the scalar product, or the inner product, and you're going to find out why it has all those names. A scalar is just a number. When we multiply these two vectors together using a dot product, the answer is not a vector, the answer is just simply a number called a scalar. The definition of the dot product is that A dot B is the magnitude of A times the magnitude of B times cosine of theta, as seen in the definition box. Notice in this definition, the vectors have to be positioned tail to tail, with the angle theta being the angle in between the two vectors. Now let's look at the consequences of this definition. If we look at two vectors that have an acute angle in between them, notice that when we multiply their two magnitudes times cosine of an acute angle, we're going to get a positive number for the dot product. Notice that in example 2, when we have an obtuse angle in between the two vectors, cosine of an obtuse angle is a negative number, so we're going to get a negative answer when we take the dot product of two angles with an obtuse angle between them. If we have a right angle, since cosine of 90 equals 0, we get a dot product of 0. So one way of identifying whether two vectors are at right angles of each other, or at right angles to each other, is to take their dot product and see if you get 0. Two other special cases: if we have two vectors that are going the same direction, like the figure on the left here that I'm putting a box around, if the two vectors are going in the same direction, the angle between them is 0. So we would end up saying 5 times 7 times cosine of 0. Since cosine of 0 equals 1, that's 5 times 7 times 1, that's where you get the 35. So when two vectors are going in the same direction, their dot product is just the sum of their the product of their magnitudes. If two vectors are going in the opposite direction, we would be saying 5 times 7 times cosine of 180, because they would be going in directions that are 180 degrees from each other. Since cosine of 180 is negative 1, that's why we end up with a negative 35 as our answer. So it's just the opposite of the product of their magnitudes. So with those things in mind, we're going to multiply two vectors using the dot product. So if we have two vectors, A and B, A being 2i plus 5j plus 7k, B is 9i plus 3j plus 4k, and we take the dot product of them, the first thing we're going to do is just distribute the dot product. So we're going to take 2i times 9i, 2i times 3j, 2i times 4k. Now I want you to recognize that I, j, and k are all at right angles to each other. So anytime I multiply an I times a j or an I times a k, I'm going to get 0. Anytime I multiply an I times itself, I'm going to just get the product of the magnitudes, because I and I have 0 degrees between them. J and j have 0 degrees between them. K and k have 0 degrees between them. So I'm just going to get the product of the two numbers in front of those two vectors. So when I do 18i times 18 times I, when I do 2i times 9i, it's 18 times I. Well, I times I is just 1, and so this is just 18. When I do 6i, or 2i times 3j, it's 6 times I times j. Well, I times j is equal to 0 because those are perpendicular vectors and their dot product is 0 because the cosine of the angle between them is 0. So that's just 0. When I do 2i times 4k, I get the 8i times k. Once again, I times k, perpendicular to each other, therefore their dot product is 0. If I do the same thing in the second row, you'll notice the only one I get a number for is the middle one, because the other two are composed of vectors that are perpendicular to each other, j and I and j and k, so you get 0 for those two, and the only one I get a number for is the 15, j times j. Third row, the only one I get a number for is the 28. This is why the dot product is also known as the inner product, because all of the outer terms, when I multiply, become 0, and so I'm just adding up those three inner numbers. That leads to a really simple formula for the dot product. The dot product can be computed merely by multiplying the i's together, the j's together, the k's together, and multiplying and adding them up, because that's all we ended up doing. We ended up multiplying the i's together, the j's together, and the k's together. So that leads to a simpler rule. I think I have this on the next page. No, I don't. So I will just write it down. The rule is that A dot B is equal to x times XA times XB plus y of A times y of B plus, this is very poorly written. I'm going to start over with this and look at actually how it's written out on the sheet. I apologize, because there is a better way to write this. There it is. If you look at the top of the page where it says Technique, Computation of Dot Product, you'll see the definition where it says A is equal to xi plus yj plus zk. And there's also designated by x sub 1, y1, z1. And if b is equal to x sub 2i plus y sub 2j plus z sub 2k, then x1 and x2 are just the x components of the two vectors, and y1 and y2 are its y components, and so forth. So the dot product is simply multiplying together the two x components, the two y components, and the two z components, and adding them up. So an easier way to have done A dot B would just be saying A dot B in this example here is just 2 times 9 plus 5 times 3 plus 7 times 4, which is 18 plus 15 plus 28, and that gives me the 61. So much simpler way to compute the dot product based on the fact that cosine of 0 is 1 and cosine of 90 is 0. Now, using the dot product to find the angle between vectors C and D. This is what we're going to mostly be using dot product for. There are many other applications in physics of the dot product, but this is the one application that we're just going to use, is how do we find the angle between two vectors. If I had two-dimensional vectors, it's very easy to draw a sketch, make a triangle, and figure out the angle between them. We've been doing that on homework. But with three-dimensional vectors, as you can see, the sketches are a lot more complicated, and it's a lot harder to determine the angle between them just by drawing triangles. It can be done, but it's a multi-step process. But with the dot product, we know this fact. We know that, in this case, C dot D is equal to the magnitude of C times the magnitude of D times cosine of theta. So if I know the dot product, and if I can find the magnitude of both the vectors, all I have to do is solve for theta, and then I know what the angle between the two vectors is. So let's just do each of those pieces. Let's start by finding the dot product. The dot product of these two vectors would be 4 times 2 plus negative 6 times 5 plus 9 times negative 3, which would be 8 minus 30 minus 27, which gives me negative 49. And this problem is done on your handout, but I just want to talk through the steps with you. The next thing I'm going to do is find the magnitude of the two vectors. Well, this is something I haven't mentioned, but it was mentioned earlier on the sheet. There's something called, there's a Pythagorean theorem for 3 dimensions. So just like we have a Pythagorean theorem for something I plus something j, and we just do the square root of the x component plus the y component squared, we can just take the square root of x squared plus y squared plus z squared to find the magnitude of the vector. In this case, it would be the square root of 4 squared plus 6 squared plus 9 squared. Yes, it is -6, but when you square it, it becomes positive 36, so I'm leaving the square off because it's just simpler to write down that way. And that turns out to be the square root of 133. In the same way, we can find that the vector d is the square root of 38. The square root of 2 squared plus 5 squared plus 3 squared. Now I have everything I need, and I'm going to say I'm going to go back to my definition, that the dot product is the magnitude of C times the magnitude of D times cosine of the angle between them, and say -49 is equal to the square root of 133 times the square root of 38 times cosine theta. So what I'm going to do on my calculator is take -49, divide it by the product of these two vectors multiplied together, the square root of 133 and the square root of 38. That's equal to cosine theta. So inverse cosine of all of this is equal to theta. And that's how you find the angle between the two vectors. Be careful when you're doing this on the calculator that if you're on the 84 to put parentheses around both of these, be careful of your parentheses, or multiply them together first and then take -49 divided by those two. So that's the information about the dot product. I hope that is helpful in clarifying what was on your sheet. Yeah, I'm teaching the dot product. I'm just opened something accidentally that I didn't mean to open, but I'll show you what they end up being like. Come on. Alright, did it save? I hope it's saved. It's still recording.